Very good morning to everyone. Still it is continuation for the Bohr's atomic model. So in the last classes, postulates completed and energy calculations, radius calculations, velocity calculations, time period, frequency of revolutions, the corresponding formulas we have covered, right? Now we will see some important energy terms involved for a single electronic system. వీటి మీద కూడా ఒకసారి క్వశ్చన్స్ వస్తూ ఉంటాయి. We should have some basic idea about this. Some important energy definitions. Or energy terms instead of energy definitions. A single electronic system. A single electronic system anna just hydrogen like species. Hydrogen like species anna single electronic system. Hydrogen, it has a single electron, so we can say that single electronic system or hydrogen like species. Before that we should have some idea here what is a ground state or excited state. Let me take a nucleus. Around this electron may revolve in various shells. So according to Bohr, the electron may revolve in a particular orbit with a fixed velocity something. Let us assume here electron is present here. This is the first shell immediately after the nucleus, and this is the second shell and the third shell and so on. And if electron present in the first shell, then this shell we can call but this is for single electronic system. We are talking about for single electronic system, not for multi electron. In case of single electronic system, if electron present in the first shell, and this shell we can call, or that energy state is called ground state. That is the first state of that electron. After that we have the second shell, third shell, fourth, fifth, up to infinity. The remaining shells, all these together, they are called excited states. Other than ground state, we can call it is the excited state. Now the electron energy present in the ground state is called ground state energy. If electron present any of the excited state, then that energy we can call excited state energy. Mostly they'll ask the question, what is the first excitation energy, second excitation energy, third excitation energy, like these questions. So a second shell is called, this is a, if electron jumps from this first shell to the second shell with respect to this ground state, and this is the first excited state, even though it is a second shell, but this is the first excited state, and this is the second excited state, and third excited state, and so on. We have excited states. Now let us take the definitions for this. First of all, first ground state. Generally, which is a ground state means in terms of, we are defining this with respect to energies. So we know that if electron present very close to the nucleus, it is having the less energy. So lowest energy state we can call ground state here, right? So first shell, among all shells, this is having the very lesser energy, smaller amount of energy. So that is the ground state. How can we define? The lowest energy state is called ground state. And the second one, excited state. Excited state means other than ground state. Energy state or energy shell. State nothing but orbit or shell. Energy state other than ground state. Energy state other than ground state is called excited state. In case of ground state, for single electronic system n equal to 1, but whereas excited state n is not equal to 1, but n may be equal to 2, 3, 4, 5, 6, so on. What is the n? N nothing but here number of shell. If n equal to 2, then that is called first excited state. n equal to 2 అయితే దాన్ని ఫస్ట్ ఎగ్జైటెడ్ స్టేట్ అంటాం. If n equal to 3, that is called second excited state. If n equal to 4, it is a third excited state. Like this, so on. N equal to 5, 6, 7, almost the number. If the fifth excited state means n equal to 6. If it is a 100 excited state means n equal to 101. Why? Because they'll ask the question here, calculate the energy in the second excited state or calculate the energy in fifth excited state, like these questions. So you should have the basic idea what is the meaning of first excited state and what is the second excited state. So third excited state ante ardhamenti idea unte you can do the calculations easily. I will see some basic questions here. Find the third excited state. Find energy of third excited state. What we have to find out? Energy we have to calculate. Find energy of third excited state of helium plus. So find the energy of third excited state of helium plus ion. Why? Because we are discussing only for single electronic system. Helium plus means it has one electron. Only if you take normal helium, it has 2 electrons. So after removal of an electron, we will get helium plus. So what should be the solution here? Third excited state. Third excited state means n equal to 4. And helium means what is the atomic number? Z equal to 2. And they are asking to calculate the energy. What formula we have for energy? E equal to minus 13.6 Z square by N square. This is in terms of electron volts. Here you know the z value, here you know the n value. You substitute there, you will get minus 13.6 into 2 square, 4 by 4 square, 16. So minus 13.6 by 4. So that is the answer. So like this you have to calculate. Next we have ionization energy. One more energy term here. Ionization energy. What does ionization energy means here? Just we have to remove the electron from valency shell. In case of single electronic system, the valency shell nothing but ground state. So energy required to remove the electron from ground state to the infinity. Here outside of the atom means infinity. So you can write the definition. The minimum energy required to remove electron from where? From ground state to the infinity. From ground state to infinity. That is called ionization energy. So means we have to transfer or we have to excite the electron from N1, means from one shell to second shell, means final shell is infinity. Here N1 equal to 1 and N2 equal to infinity. So the energy difference between these two shells, that we can call ionization energy. So again we have electron here, first shell, second shell, third shell, and so many at infinity we have final. This is the infinity shell. So now we have to excite electron from here to infinity shell. It's a kind of excitation, or we can remove the electron from here. Then electron is jumping from this ground state to the infinity. Then how to calculate this energy? The energy difference between this infinity shell and this ground state shell can give the ionization energy. So we can calculate ionization energy. IE is equals to energy difference. Energy difference between what? Infinity shell minus first shell, E infinity minus E1, that is equals to E infinity nothing but 0 and minus 1. This is minus of minus plus 13.6 z square by n1 square. We know the formula, energy difference here, and from this ionization energy is equals to n1 means here always n1 equal to 1 in ground state. So 13.6 z square. This is in terms of electron volts. This is ionization energy of hydrogen like species, or which are having single electronic system. For hydrogen case, for hydrogen atom we know that Z equal to 1, then ionization energy is 13.6. Here see, this is a positive value, it is not a negative value. We have to supplying energy, we are giving energy is nothing but positive value. So why? Because electron in the ground state it has minus 13.6 electron volt. So this much less energy it has. So we have to bring this minus 13.6 to 0 state. 0 nothing but infinity. 0 energy nothing but infinity energy. So if you supply same equal amount of 13.6 electron volts, if you supply, then you can bring this electron to the infinity state where the energy is 0. That is ionization energy for hydrogen atom. Similarly, hydrogen-like species, there is a single electronic systems, helium plus ion. What is the ionization energy of helium plus ion? If I ask, what is the question? Then the answer is 13.6. In case of helium ion, atomic number is 2. So Z square means 4. 13.6 into 4 electron volts. If I ask what is the ionization energy of lithium 2 plus ion? Again 13.6 into 3 square means 9 electron volts. So on. Like this we can calculate the ionization energy for single electronic systems, or these are hydrogen-like species. Hydrogen-like species means they are having 1 electrons. So here, apart from this ionization energy, we will use one more terminology, that is ionization potential. Sometimes ionization energy, we may use ionization potential. So here, instead of the term, in place of energy, we can take potential. Just only one difference. In case of energy, we will use the unit electron volts, but in case of potential, we will use the unit volts. For example, hydrogen ionization potential, how much it is? So instead of 13.6 electron volts, it is applied 13.6 volts. So this much potential if we apply for 1 electron charge, we can remove that electron. So in place of energy, if we use a potential, the sign will change, like instead of electron volt, we can take potential. This also you should remember. Okosari energy place lo potential and mention chestu untadu. So numerical, the method is the same, only unit okate marutundi. Next, one more energy term, excitation energy. Ionization energy, after that we have excitation energy. Excitation energy means this is the energy required to excite electron from ground state to the any of the excited state, not to infinity, except infinity, any of excited state. Again, the minimum energy required. The minimum energy required to excite electron. To excite electron from ground state to any of excited state. Any of the excited state, that we can call excitation energy. Any of excited state means, again let us take here nucleus, around this we have the orbits. Let me take like this, some various shells are there like this. Instead of writing complete circle, I am writing like this. Here this is the ground state, the first state, and the except this ground state, this is the first excited state. And the second one, this is the second excited state. This is the third excited state. This is the fourth excited state, and this is the fifth excited state, and this is the sixth excited state, where n values here n equal to 1, 2, 3, 4, 5, 6, 7. So n equal to 7 means sixth excited state. Now it is the minimum energy required to excite electron. Here we have the electron in the ground state. So we have the electron in the ground state. To excite this electron from here to here, then the minimum energy required, that is the energy gap between the second shell and first shell. That energy we can call first excitation energy. Instead of using the excitation, we can use it is a first excitation energy. Again, if you transfer electron from here to some fifth shell, then this energy we can call fourth excitation energy. Or else if you transfer electron from here to here, and this is called sixth excitation energy, so on. So where in case of excitation energy, the final N2 value should not be infinity. Anyhow, N1 is always 1 only, will excite electron from ground state to any of the second state. It may be 2, 3, 4, 5 and so on, but not infinity. If it is infinity, then we can call instead of excitation energy, that is the ionization energy. So we have somewhere here infinity shell. So where n equal to infinity. So if we transfer electron from ground state to this infinity state, in this case this excitation energy is called ionization energy. That the definition is different. So excitation energy means just you excite electron from ground state to any of the excited state except the infinity state. These terms again you write it one by one. So here always n1 equal to 1. If n2 is equals to, it may be 2, 3, 4, 5, so on, but not equals to infinity, so on, and n is not equal to infinity. If n1 equal to 1, n2 equal to 2, and this is called first excited state. If n1 equal to 1, n2 equal to 3, this is called second excited state. If n1 equal to 1, n2 equal to 4, this is called third excited state. So now excitation energy. How to calculate the excitation energy? Excitation energy. Nothing but what? The energy difference between the two shells only. That is the first shell and final shell. We know that energy difference is equals to 13.6 into z square 1 by n1 square minus 1 by n2 square. In the last class we derived this, and from this what is the n1? Always n1 equal to 1, but n2 is a variable here. n1 is a fixed value, n2 is a variable. So 13.6 z square 1 by 1 square 1 minus 1 by n2 square, and this is the excitation energy E. Excitation energy for any atom. Example, find fifth excitation energy. Fifth excitation energy term is here. Of lithium 2 plus ion. See the difference, fifth excited state energy is different, fifth excitation energy is different. Excited state ante directly the state, fifth excited state means n equal to 6. In that case we have the formula 13.6 into z square by n square minus. ఈ ఫార్ములా దేని ఇండికేట్ చేస్తుంది? ఇట్ ఇండికేట్స్ ఫర్ ఎగ్జైటెడ్ స్టేట్ ఎనర్జీ. ఆ పర్టికులర్ స్టేట్ యొక్క ఎనర్జీ ఇది. దిస్ ఇస్ ఎగ్జైటేషన్ ఎనర్జీ. ఎగ్జైటేషన్ ఎనర్జీ మీన్స్ is a transferring of energy, means electron transfer process. If excited in a particular state, excitation energy means between the two shells the energy. A small difference you have to identify here. So fifth excitation energy means where N1 equal to 1 and N2 equal to 6, or else we can use this formula, excitation energy 13.6 into here Z means lithium, 3 square, 1 minus 1 by. So fifth excitation energy means N2 equal to 6, 36. So you can simplify this one, you will get 13.6, 3 square means 9 into this is 35 by 36 electron volts. So if you simplify this one, you will get the answer. ఇంకొక term is the separation energy. Excitation. So similarly, excitation energy, we have excitation potential. ఇది కూడా ఉంటుందండి. Like ionization potential లాగా excitation potential. Means it is the minimum potential supplied to excite the electron from ground state to any of the excited state or excitation energy. So that potential we can call excitation potential. Same energy place lo potential you replace it. But unit instead of electron volt we will use volt. Volt ఒకటి వాడతాం. Same ఈ case last previous equation చూసుకున్నాం అనుకోండి. Here instead of electron volts the answer will get in terms of volt potential అడుగుతాయి. If they electron excitation potential ఇచ్చేసి if they ask excitation energy అన్నాడు అనుకోండి, potential place లో ఏం చేస్తారు, just you add electron volt, అది ఎనర్జీ కన్వర్ట్ అవుతుంది. Next, separation energy. Next term we have separation energy. Separation energy, this is also called binding energy. Binding energy. So we can write here binding energy B or separation energy SE. Again, what is the binding energy or separation energy? Again, we have somewhere here nucleus, then after various shells. After that, we have one infinity shell where n equal to infinity, and here n equal to 1, 2, 3, 4, 5, 6, and so on. We have so many. First, if you excite electron from this one shell to second shell, third, that is excitation energy. And if you excite electron from ground state to infinity, ionization energy. And here separation energy. Separation energy means except this ground state, if electron is present any of excited state, then the energy required to remove electron from any of excited state to the infinity is called separation energy. For example, we have the electron here in the second state. Then you separate this electron from this atom, means you bring it to the infinity. Separate cheyalante second shell nunchi infinity ki తీసుకురావడం. And that energy, the energy required in this process we can call separation energy or binding energy. And this energy we can call first separation energy. When you separate electron from first excited state to the infinity is called first separation energy. Or if you, for example, if electron is present in the second excited state, again to excite electron from second excited state to the infinity, or to remove electron from second excited state, that is called second separation energy or second binding energy. So here binding energy nothing but how strongly the electron is bound. Then to overcome that binding and the attractions, we have to supply some energy, right? That energy we can call binding energy. And the stronger bind ayi undi, and the equal amount of energy we have to supply. That equal amount of energy means ఏం చేస్తున్నాం, ఎలక్ట్రాన్ ని we are bringing from that one of the state to the infinity. So ఈ మధ్యలో ఉన్నటువంటి energy, this much energy we have to supply. So that is binding or separation energy. Got it now, this one. So now see, here we are removing electron from any of excited state. One more point you should remember here. In case of separation energy, always N2 value is infinity. Final state in the infinity. And what is the N1 value? N1 value is 2, 3, 4 and so on. And one important point you should note it down here. N1 is not equal to 1. N1 అనేది 1 అవ్వకూడదు. If N1 equal to 1, then that is called ionization energy. N1 equal to 1 అయితే ionization energy అంటాం. The remaining cases it is called binding energy or separation energy. Means if you excite electron from ground state to the infinity, what it is called? That is the ionization energy. If you excite electron from second to the infinity, it is not ionization energy. That is the binding energy. Except ionization energy, the remaining all ionization energies, kind of ionization energies, we can call separation energies or binding energies. Now you can write the definition like this. Energy required. Again, the minimum energy required to remove electron or to excite electron, whatever it is. From any of excited state. ఏదో ఒక ఎగ్జైటెడ్ స్టేట్ నుంచి ఎలక్ట్రాన్ ని రిమూవ్ చేయడం మీన్స్ దట్ you have to bring it to the infinity. From any of excited state to infinity. That we can call binding energy. So in this case, here in case of binding energy, N1 is equals to 2, 3, 4, so on. But one important point here, N1 is not equal to 1, should not be equal to 1. Then N2 is equals to infinity. Then binding energy, how to calculate the energy difference? That is 13.6 into Z square. Energy difference 1 by N1 square minus 1 by N2 square. So 1 by N1 square, we don't know what, this is a variable. Here N1 is a variable, N2 is a fixed. 1 by N1 square minus 1 by N2 square means that is 1 by infinity is 0. So you will get binding energy is equals to 13.6 Z square by N1 square electron volts. So where N1 is 2, 3, 4. First separation energy ante N1 equal to 2. Second separation energy ante N1 equal to 3. And fifth separation means N1 equal to 6, so on. Now we will see one question related to this. If first excitation potential of hydrogen-like species or hydrogen-like sample is 15 volt then calculate ionization energy and second excitation potential. Second excitation potential of that sample. This is one question we have here. Is that the first excitation potential of hydrogen like sample is given. So if they give first excitation potential, that we can write as the first excitation energy. What is the first excitation energy? FEE is equals to 15 electron volts. And what we have the formula, excitation energy formula, 13.6 Z square 1 by N1 square minus 1 by N2 square. So this is a formula for excitation energy. And for first excitation energy or for first excitation potential, what is the N1 in case of first excitation energy? N1 equal to 1 and N2 equal to 2. This is for first excitation energy. So we know that first excitation energy is equals to 15 electron volts, that is equals to 13.6 into Z square 1 by 1 square 1 minus 1 by 2 square 4. That means from this, this is 1 by 1 minus 4 means 3 by 4, that you bring this side. 15 into 4 by 3 is equals to 13.6 into Z square. Let us assume this is equation 1. This is the data they gave first excitation energy in Ilarasam. So what they are asking now, they are asking about ionization energy. What is the Z here? We don't know. It is a hydrogen like sample. It may be helium, it may be lithium, beryllium, so on. Exact okay, according to the given information, first excitation potential ki the first equation. Now they are asking first one, ionization energy. What is the formula for ionization energy? Ionization energy is equals to 13.6 into Z square. This is a direct formula for any species. And what is the 13.6 into Z square? That is 15 means 20. So now ionization energy equal to 20 electron volts. Second one, second excitation potential. What is the formula for second excitation potential? Again 13.6 into Z square. In case of second excitation potential, N1 equal to 1 as usual, but N2 equal to 3 means 1 by 9, 3 square, and that can give 13.6 into Z square into this is 1 minus 1 by 9 means 8 by 9. And what is this value? 13.6 into Z square, again from the given information, that is 20. So in place of here we can write this is 20 into 80, 160 by 9. So how much will get approximately? This is 17.7. So volts, they are asking potential 17.7 volt. This is second excitation potential.